The purpose of the p-value. How p-value is used in a two-sample hypothesis test.
Sir, we're having some trouble understanding statistics.
What don't you understand?
Well, I don't understand what a p-value is.
Yes, and how does p-value fit into statistical analysis?
Hey dudes, I had to do a drug test one time and they had to check my p-value. Can you explain p-value, please, sir?
I'll share a short video about this. Here's a formal definition of the p-value. The probability of observing a test statistic as extreme or more extreme than the one actually observed if the critical value of the null hypothesis were true. More informally, the probability of wrongly rejecting the null hypothesis if it is in fact true. A practical definition is the probability that the null hypothesis could occur by pure chance. The smaller the p-value, the more unlikely that the null hypothesis is true, and thus the more likely that the research hypothesis is true. Here's an example. We want to test whether increasing air pressure in our tires yields higher gas mileage. The research hypothesis is that increasing tire pressure from 32 to 34 psi causes a statistically significant increase in gas mileage. This is what we're trying to prove. The null hypothesis is the opposite of this. Increasing tire pressure from 32 to 34 psi causes no statistically significant increase in gas mileage. This is what we actually test with a hypothesis test. Now we conduct an experiment and take data. First we drive a certain route 6 times at 32 psi. Then we drive the same route 8 times at 34 psi. Notice that the number of data points does not have to be equal. We'll perform a two-sample t-test for the hypothesis test. First, here are our results. MPG for the 32 psi case and MPG for the 34 psi case. The mean at 32 psi is 25.15 MPG. At 34 psi, it's increased to 25.75 MPG. So gas mileage increased by 0.60 MPG by increasing tire pressure. But is this increase statistically significant? We use Excel's built-in two-sample t-test to find out. You'll need the data analysis toolpack. If you don't have it, click on File, Options, Add-ins, select Analysis Toolpack and go. Select it again. Okay, now when you click on the Data tab, you'll see Data Analysis. Click there. Scroll down. We're doing a two-sample t-test with unequal variances. Okay, select these as our first variable range and select these 8 values as our second variable range. The hypothesized mean difference is 0. That's the null hypothesis. And we'll pick an output range. Just pick some cell. And okay, you can see that Excel did the analysis. I added some comments here. This is our t-statistic. This is our one-tail p-value, our confidence level. It's 1 minus the p-value times 100%. Since this is less than 95%, we cannot be 95% confident. I'll summarize the results. The p-value is 5.6%, so we are 5.6% confident that the null hypothesis is true. This p-value is the area in one tail of our PDF, represented by this red area. This is the t-statistic that Excel gave us. The confidence level is the rest of the PDF. Since the entire area must be 1, confidence level is 1 minus p, blue area. So we are 94.4% confident that the research hypothesis is true. In our example, the p-value was 5.6%. There is a 5.6% probability that the null hypothesis is true. Thus, there is a 94.4% probability that the research hypothesis is true. Since standard engineering confidence level is 95%, we cannot claim that our research hypothesis is true to more than 95% confidence. We have no choice but to reject this research hypothesis. But since it's so close, we should probably take more data to be sure.
But dude, the gas mileage did increase.
Yes, but we can't be 95% confident about it.
I would still say that gas mileage improved.
Me too. Can't we say that, sir?
All you can say is that we are 94.4% confident.
That's good enough for me, man.
That's also good enough for me.
Bye, dudes. All this talk about p-values is making me have to go pee. Thank you for watching this video. Please subscribe to my YouTube channel for more videos.